So let's start talking about VXLAN related things. Hello everyone, my name is Toshiaki Hatano. I'm currently working at Berio, hosting company as network engineer and technical account manager. And I'm also an employee of the NTT Communications, leading telecom company in Japan. Actually, I don't have much thing to read in here because I was a university student last year, and I was specialized in network in Japan University. So the most important thing, our company is using CloudStack as our core component of our public cloud service. And we are currently providing both basic zone and advanced zone for our product, and currently planning to provide VPC for next future. But we noticed there are some problem while we are considering VPC. I think it's a common problem in IaaS provider like us. It's a VLAN ID limitation. You know, advanced zone have more functionality compared to basic zone, like NAT, firewall, load balancing, and VPN. And advanced zone also provide a VPC feature. I had many customers waiting a VPC feature in CloudStack, but VPC require isolation between VPC tiers, and also VPC tier require isolation between other CloudStack Advanced Zone guest networks. Typically, we are using VLAN for the network isolation in Advanced Zone. It's very common and typical, well-known, but VLAN ID is limited. We have only 4,000 VLAN ID, and it should be identical in a zone. And we cannot create domain more than VLAN ID because at least one VLAN ID is required for a domain. And when we provide VPC, VPC allows user to create more tier in their domain. So we have to have more network isolation method in advanced zone. That's my problem. So actually, there are already many solutions for CloudStack to isolate more than 4,000. But yeah, like private VLAN, security group isolation for advanced zone, and Q-in-Q, open vSwitch tunnel using GRE tunnel, and many proprietary SDN solutions exist for the CloudStack. But there are some limitations for the open source implementation, like Q-in-Q require switch support, and GRE doesn't allow broadcast, so it cannot allow IPv6 in work, and proprietary is proprietary. So that's why we are trying to introduce new network isolation method, VXLAN, into CloudStack. VXLAN is a layer 2 encapsulation protocol over UDP packet. And it's being standardized in IETF. And it allows 60 million isolated network in a domain. And its open source implementation already exists in Linux kernel and works in distributed manner just like VLAN. That works as learning bridge and allow setup of the one-to-n tunneling. And it also uses UDP encapsulation, so we don't need to have expensive network device to support the VXLAN, just IP packet. So I'd like to talk more detail about 1.2n tunneling. This diagram shows the basic setup of the VXLAN. VXLAN interface is created on top of some actual interface have IP address. Let's call the ether X for the actual interface. Bridge interface should be connected with VXLAN interface. I'll write there in a BR ether X -Y, and it should be connected to some VM. And initially, VXLAN is learning bridge, so host does not know where the destination host and VM is. So VXLAN uses multicast to discover the other endpoint. So initial packet VM created would be up or maybe neighbor discovery in IPv6. So it will be mapped into multicast and multicasts go into the underlying network, so it will be flooded in some way, and other host here's a multicast packet can learn the source host and source VM mapping. And then the app reply should be created by VM, other side VM. And at that time, the other host knows the mapping between the source of the app request so then the packet going to the unicast. So that's why VXLAN does not need to have multi-point tunneling, don't need to full mesh tunneling, and don't need to set up flow for the every VM and every host. Don't need to set up flow tables, so we don't need to centralize controller for the VXLAN. That's very good to implement simply because it's automatically learn the mapping of the VM and the host. Once we migrate VM to other host, it's automatically learn the mapping again. And once the mapping timed out, it's automatically disappear from the forwarding database on the host. So we can easily maintain the tunnel for the entire network. So it's work just similar manner in VLAN. So we are initially targeting KVM, hypervisor, and Linux ordinal bridge for the implementation target. Currently, OpenVSwitch also support VXLAN frame, but OpenVSwitch does not support such multicast function, so we have to set up flow table on the OpenVSwitch for current release. So we are using Linux native VXLAN driver, so we can use multicast function, and it's automatically run the setup. And only we are targeting for the guest network for this VXLAN integration. Okay. So to design the VXLAN integration, we are trying to share the logic and the UI flow with VLAN because we already know the VLAN, how VLAN works in CloudStack. So the flow is basically 3-step. When we create zone, the CloudStack assign virtual network range for the zone, and when we create network, CloudStack allocate the network ID for the network, and when we create the VM on the host, CloudStack automatically create VLAN interface or VXLAN interface on the host when it necessary. Maybe it's first, it will be first time when we create the VM on the host. But actually, there are some difference between VLAN and VXLAN. So to handle the difference between VLAN and VXLAN, we add the isolation method VXLAN into CloudStack management, and also add some network GUR called VXLAN guest network GUR, and add code like if isolation method is VXLAN, then do something to every code assuming VLAN outside GUR. Actually, there are many code outside GUR have assumptions that using VLAN for the isolation. So that's why I have to do something like that. Okay. So this diagram shows the bridging overview in the KVM guest. There are public network, and public network connected to some Ethernet interface. Let's call EtherX. And it's connected to Cloud Bridge, and Cloud Bridge connected to VR and for the public networking. And VR also have the virtual interface for the public network, guest network. And it's connected to bridge interface called BL Ether X-Y, and it's connected to the VM inside the same host with VR. And once we have a VM outside the host which VR is in, CloudStack automatically create Ether X.Y VLAN subinterface on top of the Ether X, which is pointed by some KVM traffic level, and it automatically created so user don't need to take care of the such VLAN subinterface creation. And this is what we are trying to implementation for VXLAN. It's very similar to the VLAN implementation. There are public interface and VL and BL is X-Y. The difference is we are replace the VLAN interface to the VXLAN interface in Linux. So the packet going to the VXLAN interface will just encapsulate it by VXLAN frame and go through some actual interface, let's say CloudBridge-X, and the packet going to the underlying network automatically determine which host should be targeted to, and then the packet just decapsulated by the other host, so the VM does not need to take care of what encapsulation method we are using for the network. So the most important thing, the structure for the VLAN and VXLAN is very similar. So network function like the NAT, firewall, load balancing, everything happens in VL, and VL does not change for the VXLAN. So we don't need to reinvent the network functionality in CloudStack. We can use same function, same code for the VLAN within a VXLAN, with a VXLAN. So to set up the VXLAN networking, we have to have some newer Linux kernel, like 3.7 or later. It supports Linux VXLAN kernel module, and you need IP routes to command utilities that support in VXLAN. And currently, we don't take care of the OpenVSH. OpenVSH does not have sufficient support of the VXLAN. So we have to use KVM hypervisor and with bridge interface. And some recent Linux distributions have a VXLAN support like Fedora 17 or Ubuntu 13, so we can test it with such distribution. So the difference, I'd like to present the difference in UI. So user have to separate physical network for the VXLAN guest network and choose the isolation method VXLAN in when you create a zone, and you may proceed with other network into other physical network, but at least guest network should be in separated physical network because that uses different isolation method. And then you may put the VLAN range in VLAN zone, but for VXLAN zone, you also need to set the VXLAN ID range for the VXLAN zone. It's very same flow for the VXLAN. Like VXLAN allows us to have 16 mega isolated network, so you can put more than 4,000 network ID for this input box. And then you create network. CloudStack automatically assigns the VNI for the VXLAN. Actually, this shows VLAN ID, but we may change resource of this box. But anyway, CloudStack automatically assigns a network ID for the CloudStack zone, VXLAN zone. So you may see something like this, more than 4,000 ID in the network. Okay. Let me demonstrate some packet capture in the actual VXLAN aware KVM host. The setup, we have a 3 KVM host in a physical network, same VLAN, and it's set up VXLAN interface to use the isolation method. And we perform ping from VM1 in the slide and to the VM2. I called it unicast ping. And I also perform the broadcast test for the network. VM1 produces the broadcast ping, and it will direct to VM2 and VM3. So this is packet capture. Can you see that? So left side, we show the outer packet, and the right side, it's decoded in inner frame. Initial packet, VM create app as normal network, and the app is directed to broadcast MAC address, so it will be mapped into the multicast address in outer frame. And then every VM and host knows the other endpoint of the ICMP ping, so other traffic going to the unicast, as you see in left side. So that's why we say it's learning bridge. And this one shows the broadcast ping. Broadcast ping happen very similar manner. First packet, the source of the ICMP ping require ARP resolution, so they send ARP packet going to the multicast, similar to the unicast, and then ARP reply happen to the destination of the broadcast ping. And then the all host knows the mapping of the VM and the host. So the other unicast packet going into the unicast packet in outer frame. And then broadcast ping still keep sending. So the broadcast going to the multicast, like packet number 8 shows. But every reply is unicast, so unicast going to map into the unicast in outer frame too. So almost frame going to unicast. That's what I want to say. Okay. So I'm sorry, the slide is very short, but let me summarize the slide. We are adding a new network isolation method called VXLAN, and the goal is to provide bigger substitutes, just work like VLAN network isolation. And I'd like to make as little change in UI, UX as possible. That's what I'd like to make. So I have more time, so let me demo real environment. Okay, can you see that? Okay, this is the actual KVM host that implemented VXLAN. This is also actual KVM host for the VXLAN. And okay, there are VM setting up on top of the VXLAN aware KVM host. And I perform IPath between the KVM host on top of the VXLAN aware KVM host and the VXLAN aware KVM host. So KVM host automatically runs the mapping between destination MAC address. This is VM's MAC address, and destination of the destination IP address for the this is for the KVM host. And the other side also runs the MAC address and IP address mapping for the KVM host and VM. And you will see there are VM here, and there are VXLAN interface exist in the KVM host. That will be automatically created like VLAN interface created automatically by the CloudStack. So that's all from my presentation. Is there any question for this topic? There are design doc in Apache CloudStack CWiki, so you can refer this for.
What about other hypervisors like Zen?
Currently, Zen using OpenVSH, right? So OpenVSH, once OpenVSH support VXLAN with multicast support, we can move forward with Zen, I think. But currently, the Linux device driver supports such function. So we only target to KVM host for the initial release, but future, we can support Zen hypervisor too, I think. Is there any more question? Oh, excuse me. Here you go. Is there any more question? Okay, thank you for taking time.